Greetings of the day, everyone. I'm Dr. Rohit. I'm going to talk about paired t-test in this presentation. So let's discuss about a hypothetical case CQ of the inferences about relationship where the independent variable is categorical in our CQ case C and the dependent variable is quantitative. That we deal with all the variables that involves matched pair. In this cases, the sample are paired or matched. Every observation in one sample is linked with an observation in the other sample. In other words, the sample are dependent. One of the most common cases where dependent samples occur in which both samples have the same subject. They are paired by subjects. In other words, each subject is measured twice on the response variable or the independent variable, typically before and after some kind of intervention in order to assess its effectiveness. So here you can see population 1, population 2, which in fact can be the same population. This can be before the intervention, this can be after the intervention, and then we assess them after we do the simple random sampling of the population. For example, suppose we want to assess the effectiveness of a SAT prep class. It would make sense to use the matched pair design and record each sample student's SAT score before and after SAT preparation classes. Recall that the two population represent two values of the explanatory variable or the independent variable. In this situation, two values come from a single set of subjects. These are the same students in these population. Essentially, the population is same. But each population has different value of explanatory variable. The SAT score may be different before and after the SAT class. So we want to know whether it's statistically significant or not. So here you can see these are the students with no SAT prep class and their mean score is, let's say, mu1. And these are the students, which is the same student who took the SAT prep classes and now their mean is mu2. Then we do simple random sampling of size n and c. So the subjects are paired because they're paired by subjects. So the idea behind the paired t-test, we want to know what's going on behind the paired t-test. So the idea is to reduce the two sample situation where we are comparing two means to a single sample situation where we are doing inferences on a single mean and then use a simple t-test. In this setting, we can easily reduce the raw data to a set of differences and conduct a one sample t-test. We are simplifying our inference procedure to a problem where we are making an inference about a single mean, the mean of differences. In other words, by reducing the two sample to one sample of differences, we are essentially reducing the problem from a problem where we are comparing two means to a problem in which we are studying only one mean. In general, every matched pair of data, our data consists of two samples which are organized in n pair. For example, let's think of sample 1 as before and sample 2 as after. We can find the difference between before and after results for each participant and which can give us the difference, namely before minus after, and we can label it as D. So essentially, paired t-test is based on this one sample of n differences. It uses those differences as data for one sample t-test on a single mean. That is, the mean of differences. This is the general idea behind paired t-test. It is nothing more than one regular t-test for mean of differences. Let's just briefly talk about the test procedures for paired t-test. The first step would be to state the null hypothesis. That is, there is no association between the independent variable or the categorical explanatory variable and the dependent variable, that is the quantitative response variable. Step 2 is obtain data and check conditions. Here, conditions are very important. So, I call the paired t-test as a special case of one sample t-test. It can be safely used as long as, we have to listen carefully, that the sample of differences is random or at least random in context. The distribution of the differences in the population should vary normally if we use small sample. If the sample size is large enough, it is safe to use paired t-tests regardless, because the data would be distributed normally in general. Normality can be checked by looking at histograms of differences. As long as there is no clear violation of normality, such as extreme skewness or outliers, normality assumption is reasonable. After that, we summarize the data. We find the p-value by using test statistics. Thankfully, we don't have to indulge much into the mathematics of the test statistics. Are very helpful. Softwares do that very accurately for us. And then we conclude. So coming on to the references, this is linked for one very interesting reference. It's biostatistics. It's an open textbook by University of Florida. Anyone interested can have a look at it. They have a lot of information. Thank you so much, everyone, for your time. Hope you learn more about the paired t-test. Keep subscribing to my channel for more videos. Thank you.